In this video, I wanted to go over how to graph systems of linear inequalities. Before we do that, let's recall how to graph linear inequalities. So if you guys recall, linear inequalities contains less than signs or greater than signs, or less than or greater than equal signs. And sometimes you're going to have a dashed line or a solid line. So anytime you have a less than or greater than sign without the equals on the bottom, you're going to graph it as a dashed line. And anytime you have an equality, such as less than or equal to or greater than or equal to, you have a solid line. So for example, I have two examples here. This linear inequality contains a less than sign, which does not have an equal. That means that it's going to graph as a dashed line. And whereas this one has a equal sign, right, greater than or equal, it's a solid line. You also might notice that some graphs are shade down and some are shade up. The way we do that is, or the way we know whether to graph shade up or shade down is here's one way to do it. There are other ways, but here's the way I'm going to teach you. The linear inequality must be in slope-intercept form, which means that it's in y equals or y mx plus b form. Instead of the equals, we're going to have one of these signs. That's what makes it a linear inequality. So here's how you know when to shade down or shade up. If it is a less than sign or a less than or equal sign, you're going to shade down. If it's a greater than sign or a greater than or equal sign, you're going to shade up. So for example, this linear inequality is in slope-intercept form, right? Y is on one side of the equation. And it contains a less than sign. So here's the graph of the line, but we shade down, right? So here's the graph of the line, we shade down because it contains a less than sign. Now, if it contains a less than or equal sign, the only difference this would make is that this would be a solid line, but we would still shade down. So with this one, there's a greater than or equal sign. So if it's greater than or equal, we shade up. So from the line, we shade up because it contains a greater than or equal sign. Now again, if it had been just a greater than sign, the only difference with the graph would have been that this would have been a dashed line. All right, so let's go right into a problem. Here we have a system of linear inequality, which means we have just two or more linear inequalities. So I'm going to graph the first one. So this is in slope-intercept form, so I'm good. So I'm going to identify the slope. The slope is 2 over 3. And the y-intercept is -1. So to graph this, I'm going to graph the point -1 on the y-axis. And from here, I'm going to use my slope to get my second point. So here, starting here, the slope is 2 over 3. So a rise of 2, 1, 2, and a positive run 3. So that's 1, 2, 3 to the right. So I'm going to plot that point here. And it's always a good idea when you're plotting by hand to do another point. So up 2, 1, 2, over to the right 3, 1, 2, 3. All right, so once I have my line here, I know that it's a less than sign. It does not have equality, so this is going to be a dashed line. So I'm going to go ahead and draw a dashed line like that. So it looks something like that. And then because it contains a less than sign, we're going to shade down. So from here, we're going to shade down. So something like that. Now let me graph the next one. So this one, let's identify its slope. So its slope is -1/4. So I'm going to put it as -1 over 4. And then the y-intercept is +3. So we're going to start with the y-intercept, +3. So we're going to plot the point right there. And we're going to use the slope to find our second point. So the rise is -1, the run is +4. So a rise of -1 is down 1. +4 run would be 1, 2, 3, 4 to the right. So that's my second point. And again, always a good idea to plot another point. So down 1 to the right 4 times. Okay, and because it contains equality, right, greater than or equal, we know this is going to be a solid line. So I'm going to draw myself a solid line. Looks like that. Um, line is not perfect, but it's okay. Let's see, and because it's a greater than or equal sign, we're going to shade up. So from this line, we're going to shade up. So it looks something like that. Now, I have to warn you guys that this graph right here is not the graph of this system. The graph of the system is where they overlap. So with this graph, this linear inequality, this was the line, we shade down. With this one, this was the line and we shade up. Where they overlap is this part right here. So I hope you guys can see this part. This is where the purple or reddish highlight intersects or overlaps with the green highlight. That is the solution or the graph of the system of inequality here. So really, I'm going to delete this, and the actual graph is this part right here. Where the dash line here, the dash part of this line is not part of the solution, but here where it's solid, this solid part is part of the solution. So this solid part of the line here and the shaded part here, where they overlap, is the solution. So hopefully that makes sense. Down here, I wrote some steps for you guys. If you guys want to follow those steps, you can follow those steps to graph it. Let's go through one more problem. So here's a problem that's on my math lab. So in this problem, it's a little bit different because both of these equations or inequalities are in standard form. They're not in slope-intercept form. So step 1 down here says rewrite both inequalities in y equals mx plus b form, which means I need to solve for y in each of these. So down here, I'm just going to really quickly do that. So I'm going to subtract x from both sides, right? So what I end up with is this cancels out. I get y is greater than negative x plus 5. And I'm going to do the same for the second one. So the second one is x minus y is greater than or equal to 5. And we're going to solve for y, so we're going to subtract x. It zeroes out. I get minus y is greater than or equal to minus x plus 5. But we cannot have this negative y, so we're going to multiply both sides by negative 1. Actually, let me do that in a different color. So multiply this by negative 1, and then over here we're going to multiply by negative 1 as well. So on the left side, negative 1 times y gives me positive y. And over here, I'm going to distribute this negative 1, which gives me positive x minus 5. Now, if you guys recall, whenever you multiply or divide by a negative number for an inequality, what happens to this sign is it flips. So instead of being a greater than or equal sign, it now becomes a less than or equal sign. All right. So essentially what I have is I've rewrote this equation as y is greater than negative x plus 5. And this equation I rewrote as y is less than or equal to x minus 5. Okay, so now that I have both of these equations or inequalities in slope-intercept form, I'm going to graph them. So the slope for the first one is negative 1, which is negative 1 over 1, and the y-intercept is positive 5. The second one is 1, right? There's a 1 here. There's also 1 there. So that's 1 over 1, and the y-intercept is negative 5. All right, so that's what I have here. Instead of graphing here, I'm going to graph it on my math lab so you guys can see how that looks like when you guys are doing your homework. So here's the same problem, right? So how I'm going to do that is I'm going to expand that, and let's see. So I'm going to choose a line. My first inequality, let's go back here, has a greater than sign. Just a greater than sign. There's no equality here, so I know it's going to be a dashed line. So I'm going to press this dashed line. Y-intercept is at 5 and a slope of -1/1. So y-intercept is at 5. Plot that right there. Let me try it again. So we're going to click on the line. After we selected the dash line tool, we're going to click the line. So plot the 5 here. Slope is -1, 1. So down 1 to the right 1. There we go. So now let's graph the second line. This one has an equal, right? Less than or equal, so it's going to be a solid line. Slope is -5. Y-intercept is -5. Slope is 1/1. So let's see. Let's change that to a solid line, and then click on the line. The y-intercept was -5, so -5 is right there, and then the slope was 1/1. So go up 1 to the right 1 time. So rise of 1 to the right 1. All right, so now this is where it gets a bit tricky. See how for the first one, we're going to shade up because it has a greater than sign? So visualize this line right here, and we're going to shade up. So it's going to, from this line, we're going to shade up. And then for the second inequality, we have a less than or equal sign, which means we're going to shade down from that line. So this is the second line, we're going to shade down. So this line, we're going to shade up. This line, we're going to shade down. So where do they overlap? So where they overlap is right here. So I hope you guys can see that. So let's review again. From this line, the inequality shades up, right? We're going to shade up like that. And with this inequality, we're going to shade down. So because from this line, we're going to shade down, and from this line, we shade up, where the overlap is right here. So how you graph that is you're going to take the paint bucket, and you're going to click on this region. If this was the overlap, the region where they overlap, you had to click this region. If it was this region, you click here. You click here if this was a region that it overlaps. But in this case, this is where it overlaps. I'm going to click right there. All right, so once you have that, you're going to save that, and then you're going to check the answer. And there we go. So if you guys have any questions, feel free to shoot me an email.